Track 3, Weather Information. The examiner is now going to test Robin's understanding of weather and how it affects her flying decisions.
Okay, Robin, let's move on to some other questions about weather. How did you learn about today's weather?
Well, I called flight service using 1-800-WX-BRIEF and got a standard weather briefing. If I called them earlier, I would have asked for an abbreviated briefing. Last night, I got a preliminary look at the weather asking for an outlook briefing.
So what information did the briefer give you today?
A number of things were in today's briefing. Adverse conditions, whether VFR flight is not recommended, a synopsis, the current conditions, en route forecast, destination forecast, winds aloft, any NOTAMs, and any ATC delays. If I wanted to, I could get the status of military training routes and MOAs, a review of the printed NOTAM publications, approximate density altitude information, customs procedures, ADIS rules, and search and rescue, although I hope we won't need that. Oh yes, you can also get LORAN and GPS RAIM availability.
Tell me how we're going to go about gathering weather while we're en route.
I can call EFAS, known as Flight Watch, on 122.0. This gives weather advisories pertinent to our type of flight, which is VFR, our route and altitude. Flight Watch is also the central collection point for PIREPs.
Tell me how we're going to stay abreast of any potential hazard conditions while we are in flight.
I'll listen to in-flight aviation weather advisories on the HIWAS frequency. This broadcast includes SIGMETs and AirMets.
Okay, Robin, what's the difference between a SIGMET and an AirMet?
A SIGMET warns pilots before and in flight of non-convective weather that may be hazardous to all aircraft. It covers a forecast period of up to 4 hours for events like severe icing, severe turbulence, dust storms, sandstorms, and volcanic ash. An AirMet covers less extreme events, the kind that affect light aircraft rather than the big ones, with details about IMC, mountain obscuration, turbulence, strong surface winds, icing, and freezing levels.
Good job. Okay, I asked you to plan a trip from Arlington, Texas to Abilene, Texas. Let's go over the weather for your flight. First, explain a METAR and how's it useful?
METARs are aviation routine weather reports based on hourly surface observations of airport conditions.
What does it tell us about our departure and our destination airports?
Well, for Arlington Municipal, it shows the wind is from 340 degrees at 10 knots, visibility is 10 miles, and the sky is clear below 12,000 feet. Temperature is 25 degrees Celsius, and dew point is 10 degrees Celsius. The altimeter setting is 29.98 inches. For our destination Abilene, it shows that the wind is also out of the north from 350 degrees at 9 knots. The visibility is 10 miles, and the sky is clear below 12,000 feet. Temperature is 23 degrees, and dew point is 8 degrees. Altimeter setting is 29.96.
Why do we need to know the dew point?
Well, dew point is the temperature to which a parcel of air must be cooled to become saturated. Once the air has become saturated, it can no longer hold moisture in a vapor state. In other words, the moisture will condense and become something we can see such as clouds, fog, etc., which are ideal conditions for carburetor icing.
Speaking of which, let's talk about fog and what are some of the ways fog may form?
It can form when air is cooled to its dew point or when moisture is added to already cool air.
Okay. What does the TAF indicate for the departure and destination airports?
The terminal area forecast, also known as the terminal forecast, which covers a 5 statute mile radius around our departure airport for the next 24 hours, looks really good. It's indicating that from 1600 Zulu, the wind will be 350 at 8 knots, visibility will be better than 6 miles, and the sky will be clear. And it pretty much stays the same for the other time periods. The destination weather for Abilene indicates the winds will be from 330 degrees at 13 knots, visibility will be over 6 miles, and the sky clear. The rest of the forecast is about the same. So great weather for the next 24 hours.
Not bad. Let's talk about some of the bad weather that just didn't show up in today's forecast. If it had been raining, what are some of the concerns you'd have for flying in the rain?
Besides reduced visibilities and cloud clearances, if it's raining, I also have to watch the temperature. If the wing is cold enough or the raindrops are supercooled, then the rain will freeze on impact, resulting in structural icing.
And we all know the consequences of icing. How about frost? Is this as dangerous as icing?
Yes. Frost can change the surface of a wing, which might cause early separation of airflow and loss of lift. Even a little bit of frost should be removed before flying.
Here in Texas, it's unusual to get a forecast that doesn't include at least a chance of thunderstorms. Why is that? What factors must be present for a thunderstorm to form?
Thunderstorms need a source of lifting, unstable air, and moisture to be present, and at least one of these conditions is present almost daily around here.
What is different about a microburst? When and where are these most likely to occur?
A microburst is a fairly short-lived downdraft of air that's associated with thunderstorms and convective activity. They can be hazardous to planes that are taking off and landing because when this downward plunging air hits the ground, it spreads out in all directions, potentially creating horizontal and vertical wind shears that aren't detectable by the pilot or equipment on the ground.
Let's talk about wind shear. What is it and where is it most likely to occur?
Wind shear is just an abrupt change in wind speed or direction at some level of the atmosphere. It can be a vertical or horizontal shift. Some places to find it would be at the boundary of a temperature inversion or near a frontal zone or thunderstorm.
Robin, almost as dangerous as wind shear, but something we don't have much of here in Texas. Tell me about mountain waves.
Mountain wave refers to turbulence that can occur on the lee side of a mountain as air blowing across the ridge develops a sort of wave flow, similar to the surface of water. The turbulence can extend well beyond the mountain range and gets worse as wind speeds increase. It's one of the reasons pilots should get some additional training before flying in the mountains.
Robin, very good. I'm glad we're not dealing with any of these conditions today. Let's talk some more about the weather briefing. If your destination airport didn't have a TIF, how would you have to determine the forecast at the time of the arrival?
I would use an area forecast.
What can you get from an area forecast?
It's a forecast of VMC, clouds, and general weather conditions over an area the size of several states. I use it along with in-flight weather advisories to better understand the complete weather picture. It helps me determine forecast en route weather and interpolate conditions at airports where no TAFs are issued. For north central Texas, it says that for the western half of the area, the sky will be clear or scattered clouds, and the outlook is VFR. For the eastern half of the area, the remnants of the front that passed through here are still present. It indicates the ceiling is forecast to be overcast at 1,000 feet, with tops at 5,000 feet. Visibility will be 3 to 5 miles. From 1,300 Zulu, the ceiling will be broken with 5/8 to 7/8 coverage at 2,000 feet. From 1,500 Zulu, the ceiling will become scattered at 3,000 feet, and the outlook will be VFR.
So it looks like pretty good weather for today's flight. What is the winds and temperatures aloft forecast indicating for today's flight?
Today's winds aloft forecast is for use from 1,700 to 2,100 Zulu. Data was based on an observation at 1,200 Zulu. No observation is made at 3,000 feet since it's too close to station elevation, but at 6,000 feet, it indicates the winds are 350 true at 33 knots, and the temperature is plus 10 degrees Celsius.
Explain the significance of the information from the winds and temperature aloft forecasts.
These forecasts can tell you the most favorable altitude to use based on winds and direction of flight. They can also indicate areas of possible icing by noting temperatures between plus 2 degrees Celsius to minus 20 degrees Celsius. Temperature inversions can also be determined. Altitudes where turbulence might be expected can be detected by abrupt changes in wind direction and speed at different altitudes.
Let's talk about weather charts. How and when would you use a surface analysis chart?
I'd use it in all my cross-country pre-flights because a surface analysis chart provides a ready means of locating pressure systems and fronts and gives me an overview of winds, temperatures, and dew point temperatures at the time on the chart.
Good. Very good. Tell me about the way air will generally flow around high and low pressure systems in the Northern Hemisphere.
Around a low pressure center, it will flow inward, upward, and counterclockwise. Around a high, outward, downward, and clockwise. Basically, air is sinking and piling up over a high. As this air flows outward, it moves into areas of low pressure, where air tends to push its way up.
Robin proved she has a good operational understanding of aviation weather and weather services, which is critical to making sound go, no-go, and diversion decisions. So far, this is a rock-solid check ride. In addition to what you've heard here, be prepared to respond to questions on when you decide to divert or opt to stay on the ground.
Very good. It's important to know what kind of air you'll be flying in before you set out so you can anticipate the conditions. What other charts might you use for your pre-flight preparations?
I look at a weather depiction chart because it gives me a broad overview of the flying conditions at the time on the chart, and I can get a bird's eye view of areas of favorable and adverse weather conditions from this chart. A radar summary chart helps me in pre-flight planning by identifying general areas and movement of precipitation and/or thunderstorms. We already talked about the usefulness of the winds and temperatures aloft chart to help decide on the best altitude for a flight you're planning. The convective outlook chart depicts the areas forecast to have thunderstorms, so this is something I'll definitely want to look at. The significant weather prog charts portray forecasts of a certain weather conditions at specific times. They provide forecast information from the surface to 24,000 feet. I use all these charts to build a complete weather picture.
Okay, sounds like you have a great grasp of the charts available to you. Let's talk a little more about the weather services that are available out there. How would you use ASOS, AWOS, and ATIS?
ASA stands for Automated Surface Observing System. It's the main U.S. surface weather observing system. It provides minute-by-minute observations, generating METARs and other aviation weather information. It transmits over a discrete radio frequency or the voice portion of a navaid. Also, there's often a phone number I can call to access the recording. AWOS stands for Automated Weather Observing System and broadcasts local minute-by-minute weather data directly to the pilot. These are generally older and being replaced by ASOS. ATIS is a continuous broadcast of recorded non-control information in high-activity terminal areas. It helps controllers be more efficient and keeps the radio less congested because it automates the transmission of needed weather information. It's continuously broadcast over a discrete radio frequency or the voice portion of a local navaid. I'd use ASOS or AWOS to get in-flight information and listen to the ATIS before entering or departing an airport area.
Okay, that all sounds very good. Let's check a couple of other items you have here. What's the significance of NOTAMs?
These basically consist of time-critical information that isn't known far enough in advance to publish on the charts or other publications. It's the kind of information that could affect my decision to make a flight. NOTAMs are published in a book called, surprisingly enough, Notices to Airmen. Subscribers can get the book every 28 days, and it's available on the internet.
Give me some examples of the kind of information contained within a NOTAM.
They can include information like airport or runway closures, changes in the status of navaids, radar service availability, and other important information for en route, terminal, or landing operations.
Okay, what NOTAMs exist at our destination airport today?
Not too many. The only NOTAM I see for ABI is this one, which indicates that the ABI TACAN is out of service.
What types of NOTAMs will be omitted in a pilot briefing if you don't specifically request them?
Distant NOTAMs and FDC NOTAMs already published aren't included unless I specifically ask for them. Also, local NOTAMs are only distributed locally and aren't attached to weather reports, but they're usually filed by flight service, and I have the option to request that they look these up.
Very good, Robin. Very good. Let's move on.
Robin proved she has a good operational understanding of aviation weather and weather services, which is critical to making sound go, no-go, and diversion decisions. So far, this is a rock-solid check ride. In addition to what you've heard here, be prepared to respond to questions on when you decide to divert or opt to stay on the ground.